This video is for sections 8.1, 8.2, and 8.3. This is introducing the idea of sampling. So when we have a sample, that's a small group from an entire population. Often we want to know something about a large group of people, like maybe all adults in the United States or all college students in the United States, something like that where we have a group of millions of people. And to try to ask a question to every single person would be impractical or impossible. So what we do is we select a smaller group of individuals, which is called a sample. Now what we don't want to do is we don't want our sample to over or underemphasize some characteristics of the population. That's called bias. We don't want our sample to be biased. So we want our sample to accurately represent the population. And in order to do that, what we need to do is select individuals at random. Selecting individuals at random is the best way to ensure that our sample accurately reflects the characteristics of the population. So this brings us to idea 2, randomize. Randomizing is important, and the essential feature of it is that it's fair. Looking at this table, this is the results of 2 samples, each sample of 8,000 individuals. So if you look at comparing the 2 samples here, like if I compare the age in years, we have 61.4 and 61.2. Now we're not going to get exactly the same results between our 2 samples. I wouldn't expect to get the exact same numbers because we're choosing different people. However, I would expect them to be close. And if you look at these 2 samples, all of the variables, the 2 samples are pretty similar in terms of the numbers. So that's good. That means that our sampling method is a pretty good method. This slight differences in the values of a variable in 2 different samples are called sampling error. Now, it's a little bit misleading because it's called error, and that usually makes you think that you made a mistake. But sampling error is not a mistake. Sampling error is a good thing. It's just slight differences between 2 samples. So our third idea is that sample size is what matters. The size of a sample determines what you can conclude from the data. So you need to have a sample size that's pretty big, but it doesn't need to be a certain fraction of the population, and the size of the population doesn't matter at all. So a lot of times you'll see like polls on the news where they're asking maybe 1,000 people or 2,000 people like how they're going to vote, and you might think that, well, that's not very many people to ask considering the entire population of the country is like 300 million. However, a sample of that size can accurately represent the population if it's chosen in a good way. So sample size itself is what's important. That's the key. A census, you've probably heard of that before, attempts to collect data on the entire population. So we have the United States Census every 10 years where they try to get information from every single person. It's often impractical if the population is large because some people are going to be very difficult to reach. So for the United States, they spend millions of dollars on the census. It wouldn't be practical for a business to try to reach everyone just because your return on investment would be pretty low for that. So a sample is usually the better way to go as long as your sample can accurately represent the population. So that brings us to section 8.2, populations and parameters. Parameters are used to model a population. Sometimes they're called population parameter. A statistic is a summary from sample data. So the key idea is to remember that S goes with S, statistic goes with sample, and P goes with P. Parameter goes with population. And we want our sample to estimate the corresponding parameter. So we want to be able to take our sample statistic and say, okay, this is probably pretty close to the value for the entire population. If it does that, then we can say that it's representative. So for this example, we want to determine whether the given value is a statistic or a parameter. So looking at question 1, it says a sample of households is selected and the average mean number of people per household is 2.58. So the key word in this problem is sample. We're looking at a sample of households, which means that the number 2.58 is a statistic. Looking at number 2, in a study of all 2,223 passengers aboard the Titanic, it is found that 32% survived when it sank. So this is all passengers. That means that we're looking at the entire population of passengers aboard the Titanic. That's our population in this case. And since it's relatively small, we can calculate exactly how many people survived. This is the 32%. So the 32% is a parameter. So that brings us to section 8.3, which is looking at some different sampling designs. The first one is called the simple random sample. In a simple random sample, every person is equally likely to be chosen, and every sample is equally likely to be chosen. So every combination of individuals has an equal chance of being selected. That part is a little bit harder to wrap your brain around. It's easier to think about when we see some examples where that's not the case. So just hold on to that part right now. But simple random sample, just think about, a good way to think of it is putting numbers in a hat and drawing them out. Or you can also use, different computer programs to do it, but the idea of randomly drawing numbers and then choosing for your sample who gets picked is probably the best way to think about it. Or like a lottery. You have lottery tickets, and assuming your lottery is legitimate, everyone is equally likely to be chosen. So, to make a simple random sample, what you need is something called a sampling frame, which is a list of individuals from which the sample will be drawn. Once you have your sampling frame, then you're going to number the individuals. And then you're going to draw random numbers to identify those to be sampled. And again, we are going to see slight sample to sample differences. That's called sampling variability or sampling error. It's not a problem, it's a good thing because it means that our sampling method is a good method. It means that we're getting a very representative sample of the population. Our next sampling method is called stratified sampling. So in stratified sampling, what we do is we divide the population into subgroups that share the same characteristics. And then within each subgroup, we take a simple random sample. This is called stratified sampling. And the key with stratified sampling is that you get a sample that is proportionate to the different groups in your population. So for example, you could divide the high school into freshmen, sophomores, juniors, and seniors, and then randomly select students from each grade and ask their opinion on school lunches. And the idea is that with a simple random sample, it's possible that you could, like for example, get a simple random sample that just for whatever reason ended up having a lot of freshmen. If you want to make sure that each grade is represented fairly, then you would use a stratified sample. So you would get proportionate amounts of each grade level. Our third method is called cluster sampling. In cluster sampling, you divide the population into different groups, and then you select all of the individuals in one or a few random groups. So you randomly choose groups and then survey everyone in the population. And the advantage of cluster sampling is really convenience, saving money, saving time. It makes the study more practical. So for example, if we want to get input from people who use a certain bus route, we can randomly select 5 buses and poll all the riders on those buses about the change. Now, the key difference between cluster sampling and stratified sampling. In stratified sampling, you are dividing into groups first, and then you're randomly selecting a few from each group. In cluster sampling, you're dividing into groups, and then you're randomly selecting a few groups and choosing all in those groups. So we're choosing a few from each group in stratified. We're choosing all of a few groups in cluster. So those two, sometimes it's hard for people to see the differences between those. So make sure that you're understanding the difference between cluster and stratified. Sometimes we might have a sampling scheme that combines several methods. You might randomly select boxes and then randomly select items within those boxes. Those are called multi-stage samples if you're using a few different sampling techniques or a few different levels of sampling in order to end up with your sample. And lastly, we have systematic samples. Systematic samples is when you start with a certain individual and then you choose a number to count out, and you choose however many, that is, every kth element in the population. So for example, selecting every 5th person on a list, or selecting every 10th person in line, or every 20th person who comes in the store, or something like that. That's called a systematic sample. And usually what you want to do is randomly select where you're going to start, and then from there count out however many you want in order to get to your sample. So maybe not choose the first person, but you could start with the second person, start with the third person, randomly select which person you're starting with. That ensures that you have a random sample. So for this example, we're going to identify the type of sampling used: systematic, stratified, cluster, or simple random sample, SRS. Number 1 says a market researcher selects 50 drivers under 30 and 50 drivers 30 and older. That would be a stratified sample because we're dividing into groups, in this case based on age, and choosing randomly a certain number of people in one group and a certain number of people in the other group. Number 2, a pollster uses a computer to generate 500 random numbers and then interviews the voters corresponding to those numbers. That is a simple random sample, SRS. So anytime you have randomly choosing numbers, that's a good clue that it's a simple random sample. Number 3, a college basketball team held a promotion at one of its games in which every 50th person who entered the arena won a free basketball. That would be an example of systematic, every 50th. So if you're counting out how many there are to get to the next one, that's an example of systematic sampling. And number 4, a researcher selects 3 of 12 high schools in a certain region and surveys all of the administrative staff members in each school about a potential change in the ordering of supplies. Keyword here is all. If you're surveying all of some randomly selected groups, that's a cluster sample.